Hello all, welcome to this video, and today we are going to study a little bit about the spanning tree, minimum spanning tree, and the two important algorithms that are Kruskals and Prims. All these things may not be possible in a single video, but what we can do is first I'll be teaching you basics, and then later I'll go for Kruskal's algorithm and then the Prim's algorithm. Okay, let me tell you what is a spanning tree. A spanning tree is a very important concept in graph theory. In graph theory, we study about spanning trees. Spanning tree, whenever you are discussing about this particular concept, you need to understand that spanning trees are graphs and they are actually the subgraph. Subgraph means they are part of a graph. First one, it includes all the vertices, all vertices. It include all vertices. And second one, it is connected. It is connected. And the third is it contains no cycles. No cycles. These are the most important things that you remember when you are dealing with the spanning tree. Okay. Now let's see that there is a graph here A, B, C. Now this can be called as a spanning tree of this particular graph. Okay. If this is a graph, this is a spanning tree of the graph. I can draw A, B, C. This can also be the spanning tree of this particular graph. If you observe here, this is a graph which is the main graph with us, and this is the minimum. This is just a spanning tree because it satisfies all the above conditions. It includes all the vertices. If you look at our graph, it is having three vertices, and this particular graph 1 and 2 both are having 3, and it is connected. You can see there are no vertices A, B, C which are disconnected from the graph, so I can say that it is connected. And the last one, there are no cycles. If you observe this carefully, you find no cycles, and therefore these are spanning trees. Now going to the minimum spanning tree. Whenever you are dealing with minimum spanning tree, you need to understand, you need to know the exact meaning of spanning tree. And now we'll come for minimum spanning tree. Minimum spanning tree. Whenever you are dealing with this, you must understand that given graph is always a weight graph. Weight graph, right? It's always a weight graph. It means it will be having a weight A, B, C. We'll take the same example. If you look at this graph, it is 5, 4, and 3. Now, this graph is going to have various spanning trees. I can write A, B, C. You remember, spanning tree will have all the vertices and it is always connected. Okay, and always number of edges will be number of vertices minus 1, means one edge less than the number of vertices. If you look at this, there are 3 vertices and the number of edges are 2. Okay, now if you write the weights as it is, we have got the weight, the cost of this particular graph is 5 plus 4 is equal to 9. And next, I can write another spanning tree as A, B, C, 3 and 4. Now this is going to be 3 plus 4 is equal to 7. And then the next spanning tree, another is possible, A, B, See, I can have this one, I think, yeah, 5, 3. So it is 5 plus 3 is equal to 8. Now, if you observe this, the cost of this particular graph, this is graph number 1, this is graph number 2, and this is graph number 3. If you observe these three carefully, you can find the costs are different. Cost of this particular graph is 9, this particular graph is 7, this is 8. And so in this case, minimum spanning tree of this graph, the main graph, is going to be this one, because the weight of the graph is minimum. Now the problem arises whenever you have got a very complex graph. Let me take an example: A, B, C, D, E, and F. Okay, and whenever you have got such a graph which is going to be very complex, it is difficult to write all the spanning trees of the graph and find out the minimum spanning tree. And that's why there are two important algorithms. Two important algorithms. One is Kruskal's algorithm. And remember, whenever you are finding the minimum spanning tree, always it will be having the weights. So I am giving weights here. Let me consider G also here. Okay. Let me consider G. So this is my G. Okay. And this is 2, 6, 6, 5, 6, 6, 3, 5, 1. Whenever you are finding the minimum spanning tree of such graphs with this traditional method, it is going to cost you a lot of time, and that's why you can use the algorithms like Kruskal's algorithm and Prim's algorithm. And these both algorithms will be covered in the next video. Thank you.